Hello, today I want to talk about my final project at CS334, which is called a multi-perspective projection cube. As in, given any image, I can project it into different faces, different surfaces of a cube. So here is an example of the projection cube. Um, in this example, you can see the cube is 10 by 10 by 10 with each unit is one small cube. You can zoom in here, you can see there's a smaller cubes. Uh, and it can project different images. For example, in shape 1, which is the x-axis, I can project the letter A on it. And for the y-axis, for example, I can project a C on it. So it has two images. They interfere with each other, but on the surface, you can see an A. You can see it through, and on the surface, you can see a C, the letter C. I can project something else onto the z-axis if I want to. For example, a triangle. As you can see here, that's the triangle. And there are a few minor features in my projects, which is instead of using cubes, I can use spheres. So it's a little bit slower to render if I have a bigger cube, but for 10 by 10 by 10 it's pretty small. So here, as you can see, I'm using spheres instead of cubes. And instead of showing the cubes, I can make it flat as the surface normals. Make it flat as we did in one of the assignments. And as you can see here, it's not showing the little cubes anymore, but just one big cube and images. So that's the main part of my project. The other part is that given any image, I can actually project that image onto the cube using a Python script. So for example, let's go to some images. Let's say we have a pentagon like this. I can project this pentagon onto the cube using the Python script. So let's see how it does that. It's a pentagon, right? So at first I input the name of the image, which says pentagon, right? Yep. So that's a PNG image. I loaded in the resolution. Since we have a 10 by 10 by 10 cube, the resolution is 10. Run the code, and it produced a binary image of the pentagon that can be projected onto the cube. So here, as you can see, at first it says this is the width. The width of the image is about 1100 pixels, and the height is 648 pixels. So this is a binary map. It put it into a text file. So here I can copy it, and let's go to the project. Here's the project. I put it in here with shapes. So I pasted in the pentagon binary map. If you open it, this is binary map, and it's gonna project this binary map onto the cube if I want to on any surface. So as you can see here, it has the pentagon. This is the pentagon. Yeah, I can put some other things onto another image. Let's say let's make it an X. Yeah. So yeah, as you can see, given any image, I can project it onto the cube. I want to explain the Python script a little bit and how it works. So as you can see here, the width and the height is here, and I use the width and the height to transform into a smaller binary map instead of using 1100 cubes. And I wanted to customize the size, right? So I shrink it down by dividing it by the resolution. As you can see here, the resolution is 10 and put on the ceiling. So instead of 1152 cubes, I divide by 10, so that's 115 to the ceiling is 116 pixels, and 65 by height and 116 by width. So that's the size of this 0 right here. What does that mean? It means that in each one of these position, each one of these entry in the binary map is the equivalent of 116 by 65 pixels. And I don't just, it's not sometimes in that that block there are multiple black pixels and multiple white pixels, so that's where the threshold here come in. The threshold here is equals to 0.1. That means that 10%, so 0.1 times 100 is 10% of, if 10% or larger number percentage of pixels are black, I make it a 1. So let's say right here, this first 0 right here, let's go to the image so we can imagine it better. Pentagon, wait, no, that's the hexagon. Let's go with the pentagon. The first block is right here. What does that mean? It means that 100% of it is white pixels. So there are no black pixels here. But let's say there's a block right here. This block right here will have about the, let's say if that is 11% of this block is the black pixels. This part right here is black, and 11% of that block is black pixels. Then it becomes a 1, like this 1 right here. So that's what the threshold means. If I want to have more, if I want like 5% of the block being black pixels, we convert it to a 1, I can make it a 0.05, which is the sensitivity of the conversion. And I use that conversion to put it into a pixel map, put it into a file that I can parse onto my project. So that's where the Python script come in. It can translate any image onto a binary map that I can use in here. The last feature I want to talk about in my project is that it is scalable. For example, instead of a 10 by 10 by 10, the dimension, I can make it 15. I prepare a few examples, as in a few images that you can project on here. Let's see. There are a few images that I can project here, as in, so there's an image of an arrow here, and an image of a heart here that I can project onto a 15 by 15 by 15 cube. So let's go with that. This is the arrow. As you can see, since it's 15, 15, 15, it is slightly more detailed than the 10 by 10 by 10. And I can use the heart on the other axis. Heart. Here we go. Here's the picture of the heart. And I can do 20 by 20 by 22. It's if I have a few pictures for that too. For the 20 by 20 by 20, I'm using this icon of the game Overwatch. This is the icon, and I have a picture of a rocket too. So I project those onto the cube, and it looks, since it's much bigger, as you can see, it's so 20 times 20 by times 20 is 8,000, which is 8 times bigger than the 10 by 10 by 10. So this is the icon for the Overwatch. It's still pixelated, but it has way more details than the 10 by 10 by 10. And here's the picture of the rocket. It's not very detailed. So that is my project, which is called the multi-perspective projection cube. I think it's very applicable when people are trying to do some modeling for building, for architecture, for example. They want certain size on different sides of the building, and they want it to be symmetrical. This can be very helpful, as you can use this technique to um, see what a building can look like, because a building can have this many stories and so. Thank you for listening. That is my project.